Welcome back. We're going to continue our look at section 2.2. Today we're going to be talking about the difference equation. So the difference equation has a function that takes f of x plus h, subtracts f of x, and divides by h. The f of x plus h is an expression. It's just a little bit farther away from x, and we're going to subtract f at x and divide by that little bit of a change in the x value, that h. So just hang with me here. It's a little bit computational, but you can get to this answer. Okay, so let's look at an example. So our function is f of x equals 5x minus 1. We want to find the difference quotient. So the difference quotient is, so you take f of x plus h minus f of x, you divide by h. All right, just write that down, and then you want to replace each expression, that f of x plus h, with its corresponding expression, and there's going to be some algebra. So f of x plus h, it takes x plus h, and it takes that value, that x plus h goes into f, and takes 5 times the x plus h, and it subtracts 1. So it's important that it's 5 times x plus h. That is f of x plus h. All right, and now that's expression. Now you get a minus. Now you got to be careful here. You got to distribute. F at x is our next piece here, and f of x is just 5x minus 1. All right, and then everything is going to be divided. Well, sorry. First we got to distribute, and then everything's going to be divided by h. All right, now that h hits everything. I know, so we got to do some simplification here, a little bit of algebra here. We got to distribute and collect like terms, and then we're trying to get rid of this h. Okay, so here we go. So let's send the 5 through. 5 goes through that first set of parentheses. So you get 5x plus 5h minus 1. Now that negative goes through that set, negative 5x plus 1, all divided by h. Now we're going to simplify here. We're going to collect like terms. That minus 1 cancels with the positive 1. This 5x cancels with the negative 5x, and you're left with an expression that just has h's in it, divided by h. And this is what we expect to see. This is exactly what we want to see, and so the answer is 5. So the difference quotient is 5 for this linear function. So the slope, the average rate of change, the slope of this function is somehow 5. That's what we're looking at. It's a rate, a change in y over a change in x. And notice the 5 is the slope of that line, so it actually kind of makes sense. All right, let's look at a more complicated one. This is a quadratic. So we'll start off with just the difference quotient. Again, we just begin with our formula. Our formula is f at x plus h minus f of x divided by h. All right, and we just plug in each expression like we did in the previous, but it's going to be a little more complicated, a little more algebra. So f of x plus h takes x plus h, it squares it, it adds 2 times it, and then subtracts 3. So let's write that in. So we have x plus h, the quantity squared, plus 2 times the x plus h minus 3. So that's our f of x plus h. This whole piece here is f of x plus h. Now we're going to subtract f of x. Now f of x is a whole expression here. It is x squared plus 2x minus 3. And then we're going to have to distribute that negative here in just a second. All divided by h. All right, we got a lot of algebra to do, and so you got to hang with me here. There's lots going on. We got to FOIL, distribute, and distribute again, and collect like terms. So lots going on here. So let's get started. So let's FOIL this out first. So notice there's all those pieces here. So FOILing out x plus h. So you got x times x, you get x squared. Now the inner and the outer are the same. You have an x and an h, x times h, and then h times x. And so those two gather together to make 2xh. So you double the product of the outer and inner, basically. That's happening there. So 2xh plus h squared. Now, we're going to distribute our 2 through the parentheses. And so you get 2x plus 2h. We subtract 3. Now we also distribute the negative. The negative hits the x squared, negative 2x, and positive 3. All that is going to be divided by h. We've got to collect like terms, and what we're expecting to see is an expression that just has h's in it, but we'll see that here in just a second. So first we got to combine like terms. So that x squared is going to cancel. That x squared right there is going to cancel with that negative x squared way down there. All right. Now that 2xh doesn't have anything that matches it exactly, but that 2x will cancel with that negative 2x. And then look for the minus 3 and the plus 3. You see those combine and cancel. So now everything else should have an h in it. That's what we expect to see. And so just rewriting everything again, we have a 2xh. We have so 2xh. We have an h squared, and there is a 2h left, and all that's divided by h. It's very important that we have all those h's in common. Now we're going to factor out an h and get rid of the h's in the denominator. And here we go. So pulling an h out of everything, it leaves you a 2x behind, an h, and a 2, all divided by h. This expression can now allow us to cancel the h. H divided by h is 1. And so just replace that with a 1. And so we just get 2x plus h plus 2. And that actually is the difference quotient. It's going to take calculus before we finish this problem. But then we're going to let h go to 0. Go. And so the final answer is 2x plus h plus 2, and that is the difference quotient.